Hello everyone. I will talk in this video about rational expressions. I will define them first, and then I will explain how to add and subtract rational expressions. So what is a rational expression? Well, it is simply a fraction p over q, where q is not equal to 0. Of course, the denominator cannot be equal to 0, where p and q are both polynomials. So that's the condition. So for example, this is a rational expression. All right. Now to add or subtract rational expressions, all we have to do is what we usually do when we add or subtract any two fractions. In other words, we have to find a common denominator. So all you have to do is just to apply this recipe. So first of all, I factorize all the denominators if possible. Then we find the least common denominator. And finally, we multiply each fraction by the missing factor in that denominator. I'm going to apply this recipe on two examples. So in example number 1, we have x plus 1 over x squared plus 4x plus 3 minus 3x minus 2 over x plus 1. So step number 1 in the recipe tells us that we have to factor all the denominators if possible. And yes, this denominator is a trinomial of the form ax squared plus bx plus c, where a is equal to 1, which means it becomes x plus 1 into x plus 3. How do I do that? You can refer to a previous video where I explained how to factor polynomials in details. All right. Now what is step number 2? You have to find a common denominator. And it has to be the least common denominator. So we have x plus 1, a common factor between the two fractions. So I write it once, as well as x plus 3. So that is the least common denominator. Now, if it happens that we have two factors with different exponents, we always take the higher exponent. So for example, if you have x plus 2 to the power of 3, and x plus 2 to the power of 5, we select x plus 2 to the power of 5. But in this example, it happens that x plus 1 is of exponent 1 in both fractions, so we just take x plus 1. Now, what is the next step? We multiply each fraction by the missing factor. In other words, the common denominator contains two factors, x plus 1 and x plus 3, and both of them are already in the first denominator, which means that the first denominator is not missing any factor, so we do not multiply it by anything. However, the second fraction only contains x plus 1, which means I have to multiply this fraction by x plus 3 up and down. So the fraction becomes x plus 1 minus 3x minus 2 into x plus 3. And all we have to do now is just simplify the numerator. And the final answer is minus 3x squared minus 6x plus 7 over x plus 1 multiplied by x plus 3. Let's do the second example. So here we have three fractions. The first denominator is x plus 3. I cannot factor it. It's already irreducible. As well as 3 minus x. However, x squared minus 9 is a difference of two squares, which means it becomes x minus 3 into x plus 3. Now, if you look at all the denominators, we notice that we have 3 minus x in the second fraction and x minus 3 in the third fraction. And of course, they are not the same because a minus b is not equal to b minus a. So what do I do in this case? Well, we know that a minus b is equal to minus into b minus a. So if you want to switch two terms where you have a minus in the middle, I must factor a minus. So this becomes minus into x minus 3. And after that, I multiply this minus by this minus. So the expression becomes like that. All right. We are now ready to find a common denominator, which is x minus 3 into x plus 3. Let us now check if each of these terms is missing some factor and multiply by this factor. For the first fraction, we only have x plus 3, which means x minus 3 is missing. So I multiply up and down by x minus 3. For the second fraction, we only have x minus 3, so we multiply up and down by x plus 3. What about the third fraction? It already contains the two factors that are in the common denominator, so we do not multiply the third fraction by any factor. So the expression becomes like this, and finally we just simplify the numerator, and this is the final answer. So this is how we add and subtract rational expressions. In the next video, I'm going to explain how to multiply and divide rational expressions.